Hello, and welcome back to the second episode of this financial maths series. Okay, today we're just going to be focusing on the simple interest formula. Okay, and using it to calculate interest and final value of an investment or loan. And then we'll also be calculating unknowns, principal, rate, and time by rearranging this simple interest formula. Let's do this. So these are the questions we'll be covering. So there's actually 6 questions. So maybe you want to pause the video and try these out before I go through them. So here's the first 4, and here's the last 2. So let's do this. Okay. All right, so in the last video, we looked at what interest actually is. So you might want to go back and revisit that video, but we're just focusing on simple interest. So this is a simple interest formula. Have a look at it. Capital I is the interest earned or owed. Capital P is the principal, the initial value invested. I is the decimal annual interest rate. N is the number of years. And then we use this to calculate the amount of the investment, the final value of the investment or loan. So the amount is the principal plus the interest. So let's try out the first one. All right, we can always refer back to slide 12, but let's give it a go. Okay, a simple interest loan of $30,000 is taken out for 4 years. Calculate the interest owed after 4 years if the rate of interest is 9% per year per annum. Okay, so first of all, I am going to look at what I know. Okay, a simple interest loan of $30,000. So that's the principal. So I'm just going to chuck down the principal is $30,000. Okay, because if we come back here, the principal is the initial value invested or borrowed. So we know that is taken out for 4 years. Okay, so that's our time period. So that's N. I'm going to put it in our little data table. Whoops. Okay, so calculate the interest owed after 4 years. Interest owed means capital I. If the rate of interest is 9% per annum, rate of interest means interest rate. They like to just use different terms. Fun. Okay, so interest rate. And remember, we need to have this as a decimal. So the interest rate is 9% per year. And percent means divide by 100. Okay, and a quick way to divide by 100 is moving that decimal place 2 humps because there's 2 zeros. So 0.09, we'll just chuck a 0 there, 0.09 per year is the decimal, which we use in our calculations. Okay, and then we've just got to work out what formula to use. So it'll either be the simple interest formula or the compound interest, and they give us this. So we're going to be using that PIN formula. I equals PIN. Okay, now we have all of our little variables there. Okay, let's just substitute them. 30,000 times I as a decimal times N is 4 years. Put it in my calculator. 30,000 times 0.09 times 4. 10,800. And that is the interest owed. We have answered the question. So that's part A. Okay. And I just put a box around my answer sometimes. Most of the time, just to keep track of it because I might need it in other calculations. So then what have we got? Calculate the total amount to be repaid after 4 years. Total amount after 4 years. Okay. So when we come back, after 4 years means that we are finding the final value, the amount of the investment, what it amounts to after 4 years. So that's where we have this formula, A equals P plus I. Okay. And we know that our P was 30,000 from our little data table. And our interest, we've put a nice little box around it, is that. So sometimes they step you through this process. They'll give you part A, which will give you the interest. And then you use that to calculate the answer to part B. But let's put that in our calculator. 30,000 plus 10,800, 40,800. And I should put the correct units in here. So the total amount to be repaid after 4 years is 40,800. And I always compare this amount to the initial amount that they took out. So if someone takes out a loan of $30,000, they are paying $10,800 interest at a high rate like that. So that's a lot. Anyway, I think you get the picture. Let's move on. Okay. So next one. Georgia deposits $500 into her bank account. The account, I'm just going to write it as we go, actually. Let's do a data table. She deposits $500 into her bank account. That is the principal. It's her initial value that she's looking to invest, sorry. Principal is 500. Translate as you go. Translate that English into a little maths table. The account offers an interest rate of 5.5% per year, simple interest. Okay, interest rate means our little I. And that's correct. You do convert it to a decimal. Well done. 5.5% means divide by 100. I'm sure I'm sounding like a broken record now. 5.5 divide 100. 0.055 with that little decimal trick, or just put it in your calculator like I did automatically. Okay. Per year, and I always include the units per year there. Georgia has 5 years to save for a formal dress. That's a length of time. So let's put it in here. Calculate the total interest she would earn over 5 years. The total interest she would earn over 5 years. Okay, so again, we're deciding our formula to calculate interest. Is it simple interest or is it compound interest? Looking for that keyword, simple there. So we've got our I equals PIN formula from back here. Simple interest. We've got P, we've got I, we've got N. Let's just substitute them. 500 times the interest rate as a decimal times our number of years. Put it in your calculator. Make sure you have that decimal in there. What did I mean? The zero in your calculator. Some people miss it and then that will wreck your calculation. So it should be 0.055 times 5. 500 times 0.055 times 5. Sorry, I'm distracted because I'm house sitting at the moment and the dog is snoring and I'm trying to wake it up every few minutes to stop snoring. Okay, so that is our interest. All right, so calculate. Have we answered the question? Yes, we have. Calculate the total interest she would earn over 5 years. Okay, part B. If Georgia used all her savings, determine the most expensive dress she could afford after 5 years. Before I do that, I am going to put a box around my little answer here because I might need it later. That makes it easier to find. The most expensive dress she could afford after 5 years. So she's earning interest on her bank account, right? On her investment. And so she's hoping that she can afford a little bit more of an expensive formal dress at the end of her schooling. Okay. So let's have a little look. That means that she wants it to amount to a value. She's looking for what the future value will be. Okay, the present value in her bank account is 500. The future value, this is where we do that thing. If we go back to 12, the future value is that. So then we've got the principal is 500 plus the interest, and put that in our calculator. This is going to be the future value in her bank account. So the most expensive dress she can afford. All right. And that's the answer. And you might want to write a little sentence if that's an exam question. The most expensive dress that she can afford is this much. Okay. So let's get another one going. Find the total amount owed on a simple interest loan of $14,000 at 6.5% per year after 2 years. Okay. Well, I'm just going to write down what we know first. Okay. So I'll say simple interest, SI, loan of $14,000. So loan means that initial value, remember, the amount borrowed or invested. And that will be the amount borrowed or invested. The initial value is called P. 6.5%. Okay, that is the interest rate as a percentage. Okay. Sorry, I'm still listening out for that dog snoring. And it is. And it just falls asleep so quickly. It's too hilarious. Okay, but anyway, let's try and concentrate on this because I'm sure you can't hear that. So we've got 6.5% as a percentage, as a decimal. Again, percent means divide by 100. 0.065. And put your units in there. So per year, after 2 years, N is 2 years. So you need to always have consistent units here, but we'll come across that in a video soon. Oh no. That's not good. Whoops, sorry about that. Let's get that going again. All right. So 0.065 per year after 2 years. Well, we know that N is 2. Now, reading the question again, find the total amount owed. Okay, A equals total amount owed. All right. Now, what can we do here? So, first of all, I'll just write down a few formulas. So, simple interest. Simple interest formula is I equals PIN. If we come back to here, oops, these are the two formulas that we can use to find things. I equals PIN and A equals P plus I. So I'm just going to write them down straight away and see how many unknowns we have and if we can solve. So I've got P, I've got I, and I've got N. So as you can see, it might make sense to use this to find I. Okay, and then once we have I, we have P, and we can find our A. So if ever you're confused, just write down the formulas, and if you've got more than one unknown, you need to do something else. So I is PIN, let's go, 14,000 times I as a decimal, times our number of years. Into the calculator we go. Times 0.065 times 2. $1,820. Again, box around the answer. Okay. And we're just going to substitute that straight in to find our total amount owed. The P was 14,000 from our little data table. And let's do it. 14,000 plus 1,820 gives us 15,820. And that is our total amount owed. Total amount owed. And once again, just check your answer makes sense. So $14,000 was the present value, and it's amounting to a future value of 15,820. Okay, so yeah, nearly paying a couple of grand in interest there. Just to borrow some money, you've got to pay that fee. Okay, let's do this. Now pause the video if you need to just take a break, because I'm going through it quickly. So I'm trying to make these videos short, but I don't think I'm going to reach the 20-minute mark. And now I'm wasting even more time talking. But anyway, go and rest if you need to and come back to it. And we've got 3 more questions to go. Okay, let's do this. So determine the number of years that $3,000 should be invested at 6.25% simple interest to earn $1,000 interest. Again, data table. So determine the number of years. Okay, well, that's an unknown. That $3,000 should be invested. Okay, so $3,000 should be invested. So that's our initial investment. So that means it's our principal, P. At 6.25% simple interest. Okay, that's a rate. Okay, an interest rate, little I. As a decimal, put that in your calculator, 6.25 divide 100, 0.0625 per year, always include the units, to earn $1,000 interest. To earn $1,000 interest. Okay. So this time we've got something that we haven't seen as of yet. All right. So first of all, write down a formula that you might be able to use that links these variables. So it's going to be either simple interest or compound interest. Luckily, it's simple interest. Okay, so we're going to write down the formula. And we're just going to, let's substitute. See what we have, because we've got a formula linking these 4 variables and there's only one unknown, which means we can rearrange. So I is 1,000. So we're actually going to be substituting on that left-hand side as well. P is 3,000. Little I as a decimal is that. So just substituting in. N is our unknown this time. Okay, so we've got to get N on its own, and it's being multiplied by these 2 things. So what is the opposite of multiplying? This is what you have to ask yourself. The opposite of multiplying will undo this side of the equation. All right, so what we are going to do, we're going to divide by those numbers on both sides, and then they're going to cancel out. Okay, and you can divide them in one hit like that. All right, and you can feel free to cancel like that. And I'm going to write the N on this side, but let's do this. So, and make sure that you put brackets around your denominator, or things will not go your way, all right? So 1,000 divide 3,000, so bracket 3,000 times 0.0625. Okay, it's given me 5.33 years. And we know our answer will be in years because we put the interest rate in as per year. Okay. So then if they ask for that as the number of years and months, which they might do sometimes, okay, we can put that as 5 years plus 0.33 years. So split it up. And then you want to actually get this bit into months because you don't like to say it's 0.33 of a year. Okay. So to do that, you work out, okay, well, there's 12 months in a year. So I'm going to want to multiply by 12 because you want it to be a bigger number, right? Since there's a lot of months in a year, if that makes any sense. 0.33 times 12 gives 3.96. Let's say just about 4 months. Okay, so that's our answer. 5 years and 4 months. And then let's just check it sort of makes sense-ish. The number of years at $3,000 should be invested to get $1,000 interest. Okay, seems about right. Yep, nice. Okay, so 2 more questions to go. Hang in there. These are all the different question types that you might find. So you've got to go away and practice these. All right. For how long, okay, well, we know that that's time, right? Must $8,000 be invested? Okay, $8,000 be invested means that's our initial value, which is our principal. That starting value is our principal. At 4.5% per year, that's our interest rate, 4.5% per year. As a decimal, since percent means divide by 100, move that thing like that, 0.045. And make sure you keep all those decimal places too. Okay. And I'm going to put in my units per year. Simple interest. I don't know. I'm just going to write down the simple interest formula because what I know about that. And thing that it amounts to is P plus I. The dog's snoring again, hoping you can't hear it. I might cry if I have to do this again. Anyway, already cried. All right. Simple interest to have a value of $9,500. To have a value of $9,500. So that means the thing that it's amounting to. I'm going to put in my A. It's 9,500. Okay, so A is always bigger than P, right? If that helps anywhere. A is greater than P. If ever you're confused about which one is which. A is bigger than P because you're adding on that interest. Okay, I'll stop talking about that now. So we've got to add down any possible formulas. Now let's read the question again since I've interrupted so many times. For how long must $8,000 be invested at 4.5% per year simple interest to have a value of $9,500? All right. So again, looking at this, we've got 4 variables and they're all linked in this equation. So let's just substitute. Let's substitute in and find what we can. It is a bit of a weird one, actually. Hang on. Let me think about this. Okay. Actually, so I, we don't have I. P, we do have P. I, we have I, but we don't have N. So there is too many unknowns for this one. But then we come over here, all right? We have A, we have P, and that means we can find I since there's only one unknown. So we're actually going to start with this formula this time. So they love to confuse us. They love it. Okay, so let's substitute in. We've got A, so again, substituting on the left-hand side will have to happen sometimes. 9,500. P is 8,000. I is our unknown. Now, since 8,000 is being added to I, there's a little imaginary plus sign here. You are going to subtract it from both sides. So maybe I'll get a different color. We're going to subtract that 8,000 from both sides. Okay. And we've got to do that. Got to do it in that order. Okay, so 9,500 take 8,000. Into my calculator, 1,500. I mean, I could have done that in my head, but it's all right. So now we have this. I'm going to put a box around it. Okay. And we check, have we answered the question? No, we haven't, because it's saying for how long. So we've got to find that little n. So let's say this was step 1 and this is step 2. So into here, let's substitute all of our values. Now that we have I, let's substitute in I from our box thing. So 8,000 is P. I is our decimal. Don't forget that. Oh no, I'm running out of space. Let's move that over. Whoops, too far. Okay, and times it by n, which we don't know. Okay, again, n is our unknown. We ask ourselves, okay, what's happening to the n? It's being multiplied by these numbers. What's the opposite of multiplying? Dividing. So that will undo our equation. We're going to divide by both of those numbers. And when I put it in my calculator, I'm going to make sure to have brackets around that denominator. So again, these will cancel. I'm going to get a, oops, that will cancel. And we'll be left with n. Okay, so I'm just going to put n on this side, switch them over, and put this into my calculator. 1,500 divide 8,000 times 0.045. Now that gives us 4.17. And I know it's years because that's what I input into it. Years. And if you wanted to do it as years and months, we can break that up. 4 years plus 0.17 years. 4 years. And how many months? Well, we times it by 12 because we want that bigger number. We want it to be a meaningful number of months. So about 2 months. 4 years and 2 months. Okay, and that is our answer. I'm just going to write in the interest of saving time here because I wanted to make, you know, that 20-minute mark, and now we're at 29 and I can't afford a video editor. So let's keep going. This is the final question. Okay, use the simple interest formula. Well, I may as well write it down. To determine the annual interest rate. Okay, let's write a little data table then. Annual interest rate. So I'm just going to put something per year. And note that your interest rate, they will want that as a percentage. So a lot of people leave their answer as a decimal. So write that in, check it at the end. Okay, so to determine the annual interest rate, when $5,000 earns $150 interest in 2 years. Okay, so when $5,000 earns 150, so that's our principal, it's 5,000. It earns some interest, earns $150 interest in 2 years. Okay, that's our time, 2 years. Put in our little things, and I've written the formula, and look, we've got this formula links all the variables. We've got an I, capital I, we've got a P, we've got, well, we want to find that, and we've got our N. So let's chuck it in. 5,000 times I, well, we don't know I, times N, which is 2, capital I is 150. Again, we want I on its own. Just going to get a different color. It's being multiplied by both of these numbers. What's the opposite of multiplying? Dividing. So that's what we have to do on both sides to isolate that I. 5,000 times 2. Let's do this. And that's all going to cancel, actually. I mean, not all of it. So I'm just flipping it around. So the I is here, and the 150 divided 5,000 times 2 will be there. Remember the brackets around that answer when you put it in your calculator. Okay, 5,000. There we are. 0.015. Okay. Now, have we answered it properly? This is I as a decimal, which we'll always get from our calculations or input into our calculations. Remember to convert from decimal to percentage, because that would be a very low interest rate. Not everyone would be taking out loans if the interest rates were that low as a percent. So we've got to convert it back. So before we divided by 100 to get to a decimal, so we are going to times by 100. Times it by 100 to get to a percentage, back to a percentage. 0.015 times 100, 1.5%. So still pretty low interest rate. All right, 1.5%. So it's not really earning too much interest. You wouldn't really want to put your money in that bank account. I mean, maybe. I don't know. All right, I will leave you be and stop blabbing on. This is what we are going to cover next time. We're going to go compound interest, and there's a whole lot of problems that I've compiled together for that. And then the video after that, we're going to be doing compound interest with like monthly, quarterly rests. Okay? So compounding monthly, quarterly. But I'll stop, and now I've knocked off my microphone. All right. Thanks heaps.